Hi everyone, my name is Arlen Fan. I'm going to talk about our work understanding reader takeaways in thematic maps under varying text, detail, and spatial autocorrelation done at Arizona State University. The main topic of today's talk is thematic maps. Maps are not just a navigational aid, they are powerful geospatial visualization tools. They come in many variants and show the distribution of themes or variables across an area. On the title slide, I showed a choropleth map. Here I showed an isarithmic map on the bottom and a cartogram on the top. Isarithmic maps, with their contour lines connecting points of equal value, offer us insights into the continuous data such as elevation or precipitation levels. And then there are cartograms, which distort geography to emphasize the size of the data, making abstract statistics more accessible. But here lies the challenge. How do we enhance these visual narratives with text annotations without overwhelming the viewer? The key is to integrate text cues seamlessly with the design to enrich comprehension. Our goal is to strike the balance where text and visuals complement each other. We follow the following framework to guide our experimental design variables. Let's begin with semantic level 1 or L1. At this foundational level, we deal with the elemental properties of our maps. This includes the type of chart used, the encoding channels, the title, and the labels. Annotations here are perceiver independent, meaning they are objective and not open to interpretation. Moving to semantic level 2 or L2, we introduce descriptive statistics. Here, the annotations might highlight outliers, show extrema, or make point-wise comparisons. Much like L1, L2 remains perceiver independent, providing concrete quantitative information that doesn't change regardless of who's viewing the map. With semantic level 3 or L3, we delve into the perceptual aspects. Annotations at this level interpret trends and patterns that begin to depend on the viewer's perception. This is where subjectivity creeps in. Two people might see different stories in the same lines and colors, influenced by their backgrounds or how they interpret the visual cues. At semantic level 4, or L4, we reach the most interpretive layer. Here, annotations are enriched with external information that provides deeper context to the map's primary topic. They are perceiver dependent and invite viewers to understand the data within a broader narrative frame such as socioeconomic or historical context. Next, we move on to map types. We focus on 3 choropleth maps, which use color gradations to represent data within geographical areas. Isarithmic maps, which connect points of equal data value with lines to highlight gradients and transitions. And then finally, hexbin or cartogram maps, which space is transformed to emphasize the data metric, often resulting in a visually compelling abstract representation. The map detail is another vital aspect, whether we're looking at the larger state level or the more granular county level. The choice here affects the map's legibility and the viewer's cognitive load. Too much detail may overwhelm, too little may oversimplify. Spatial autocorrelation refers to the similarity of a feature like a data point to its neighbors. High spatial autocorrelation means that nearby places are likely to have similar values, revealing clusters or patterns that can be important for certain analyses. Finally, text detail must be thoughtfully aligned with map detail. If the map shows a state-level data but the text dives into county-specific statistics, then we consider it misaligned. Conversely, when they're in sync, we consider it aligned. This is a concept that, to our knowledge, is only used in our study. Here, I'll show some example maps with variables. This map is a choropleth map. It uses semantic level 3 annotations. It's at the state detail. The spatial autocorrelation is measured by Moran's I, which is 0.41, and the text detail is different than map detail because the text detail refers to regions such as Southwest, Southeast, Midwest, New England, which do not align with the state map detail. Here's another example map. It's at the semantic level 4 annotations. It's a choropleth map. It's at the county level. The spatial autocorrelation is measured by Moran's I, with a value of 0.46, and the text detail is same or aligned with the map detail. Here is one final example. There are semantic level 2 annotations because these are descriptive statistics. The map type is a cartogram or a hexbin, and the map detail is at the state level. The spatial autocorrelation is 0.13 measured by Moran's eye, and the text detail is same as map detail. Based on this, we formulated targeted hypotheses concerning the impact of map type, geographic detail, text content, and spatial autocorrelation. We evaluated 3 primary factors: source, detail, and semantic level. The effect of map design features on the source addresses research question 1. In what ways does map design shape the primary source of the reader's takeaways? The influence of map design on the detail or granularity of takeaways explored in research question 2. How does the design of the map alter the depth or granularity of the reader's takeaways? Lastly, research question 3 investigates the influence of map design on the semantic level of readers' takeaways. How does the design of map impact the semantic level at which readers interpret takeaways? For each research question, we write 3 hypotheses, A, B, and C for each research question. For each research question, we write 3 hypotheses, A, B, and C for each research question. For each hypothesis, we have a brief explanation of why we made this hypothesis. H1A, map type affects reliance on text annotations because cartograms and similar distorted maps increase reliance on text due to their unfamiliar visual forms. H1B, enhanced geographical detail on maps leads to a greater dependence on text annotations as finer details raise cognitive load, necessitating clear, high-level semantic guidance. H1C, high spatial autocorrelation may lessen the necessity for text annotations because maps with such features exhibit more apparent patterns, although this could vary with map type. H2A, the type of map influences the level of detail in the reader's takeaways, with certain types like isarithmic maps drawing focus to broader areas. H2B, the detail of takeaways changes with map detail, where alignment of map and text detail can affect the specificity of a reader's interpretation. H2C, high spatial autocorrelation tends to result in broader, less detailed takeaways, as it often indicates clustering, which leads to generalized interpretations. H3A, map type determines the semantic level of takeaways, with certain types such as isarithmic maps prompting more abstract, high-level semantic processing. H3B, less detailed maps can prompt takeaways with higher semantic level because larger area descriptions tend to be more abstract. H3C, the degree of spatial autocorrelation affects the complexity of the semantic level of takeaways with higher autocorrelation, especially in maps like isarithmic ones, leading to more intricate and abstract interpretations. For the analysis of the results, 2 of the authors independently coded the results for detail and semantic level. We ran the results through a rigorous statistical analysis using fixed effect tests to determine if any of the input variables had a significant effect on the output variables. We will run through a sample analysis for hypothesis H1A here. For the sake of time, the analysis for all 9 hypotheses will not be included on this slide. For a more in-depth discussion of the quantitative methods applied, please consult our paper. Recall hypothesis H1A and research question 1. Map type will influence a reader's reliance on text annotations. Map type and its interactions with semantic level will have an effect. We note that map type does not have a significant effect on source, as a p-value is greater than 0.05. However, we do see that map type times semantic level is significant on source. This means that the effect of map type on source depends on semantic level. We will delve deeper into this by building a proportional odds model. We model the probability that the source is higher, which means that the reader derived more information from the map. When reading a choropleth map, readers are 2.12 times more likely to report being relying on the map when reading perceiver-independent annotations versus perceiver-dependent annotations. When reading isarithmic map, readers are 1.27 times more likely to report being more reliant on the map when reading perceiver-independent annotations as opposed to perceiver-dependent annotations, although this is not statistically significant at a p-value of 0.085. For hexbin maps, this effect is more substantial. Readers are 2.86 times more likely to rely more on the map when they are provided with perceiver-independent annotations compared to perceiver-dependent annotations, with this result being statistically significant at p is less than 0.001. Here we summarize our key results. The effects of geographical detail. Higher geographical detail, such as county-level maps, leads readers to rely more on text and produce higher semantic-level takeaways, possibly due to the fact of overwhelming information on detailed maps. The takeaway from this is to utilize less detailed maps, such as state-level maps, with corresponding text annotations to encourage more detailed takeaways. Effects of semantic level. Text annotations with higher semantic levels, or perceiver-dependent annotations, result in coarser and higher semantic level takeaways. Therefore, dependent level annotations facilitate broad or high-level understanding of the map dataset. Spatial autocorrelation and map type. Spatial autocorrelation influences the detail of takeaways depending on the map type, not significantly affecting the source of takeaways or text reliance. Balancing visual complexity with semantic detail. Map type affects the depth of understanding derived and the reliance on text. Isarithmic maps induce readers to seek clarity from text. Hexbin and choropleth maps motivate readers to extract information directly from the map. Therefore, select map types strategically based on desired understanding depth and reliance on the map versus the text. Unique characteristics of isarithmic maps. Isarithmic maps encourage higher semantic level takeaways, but may lead to coarser detailed takeaways. Isarithmic maps diverge significantly from hexbin and choropleth maps in perception. Thank you for listening to our talk. I'm open to any questions.